So question is given that fx is equal to limit n tends to infinity n raised to the power n, x plus n, x plus n by 2, and so on, x plus n by n. And in the denominator it is given that n factorial x square plus n square, x square plus n square by 4, and so on, x square plus n square upon n square. And the power of this expression is x upon n. So we can clearly see that we can take n common from this term, n by 2 common from this term, and n by n common from this term in the numerator. And in the denominator we can take n square common in this term, n square by 4 common in this term, and n square by n square common in this term. So let's take common limit n tends to infinity n raised to the power n, n x by n plus 1, n by 2, 2x upon n plus 1, and so on, and n by n, n x by n plus 1. So, and in the denominator n factorial n square x square upon n square plus 1, n square by 4, 4x square upon n square plus 1, and so on, and n square upon n square, n square x square upon n square plus 1 in denominator. And the power of this function is x upon n. So we can clearly see that there is n in numerator n times, and we in the terms which we have taken common is 1, 2, 3, and so on. So this will become n tends to infinity. This will become n raised to the power n, and because n is n times common, so we can say that n raised to the power n. And in the denominator you can say, so there is 1, 2, 3, and dot 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 n. So this will become n factorial. N factorial. One n factorial was given before. So in the other terms this will become x by n plus 1, 2x by n plus 1, and so on, and nx by n plus 1. But in the denominator this will become x n raised to the power 2n. Why? Because n square is common n times, so we can say so. And if you look at the denominator terms which we have taken common, this is 1, 4, and n square, so we can say it square of n factorial, and this will become x square plus n square plus 1, 4x square upon n square plus 1, and so on, n square x square upon n square plus 1, and the power of this is x by n. So from here these terms will be cancelled out, and the remaining term is limit n tends to infinity. This will become the greater pi, it means the multiplication of all r from 1 to n, r from 1 to n, or you can do it with other method. We will do it with other method. Okay, so let it write it simply: 1 upon x upon n, 1 upon x upon n, and this is 2 dot 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 1 upon nx upon n, 1 plus x square upon n square, 1 plus 4x square upon n square, and so on. this is our fx. So if we take log of both sides, log of both sides, taking log of both sides, this will become ln fx, and limit n tends to infinity. This when we take log of this expression, x upon n will come out, and this will become ln. What will be it? It will become sigma 1 plus rx upon n. Let me explain, where r is from 1 to n, and minus limit n tends to infinity x upon n ln sigma r is equal to 1 from n square and 1 plus rx upon n square, or you can take it simply as n. This will become r square. So this will become r square upon x square. So if you can clearly see from here, there's this is a question kind of limit of some concept, because there is 1 by n sigma and limit of n is tending to infinity. So if we take r by n as y, so 1 by n will be dy, and the limits will be from 0 to 1. So if we see that ln fx will be integration of 0 to 1 x ln 1 plus xy dy minus x 0 to 1 ln 1 plus x square y square dy. We can solve these integrations easily. So this will become xy, let us say xy is equal to t, then x dy will be dt. So and the limits will be, upper limit will be x and the lower limit will be 0 if we put y1. So this will become from here. So now we will get ln fx is equal to from 0 to x ln 1 plus t dt minus 0 to 1 ln 1 plus t square dt. So you can differentiate both sides to get the value of fx and f dash x. Differentiate both sides. So we will get f dash x upon fx is equal to ln 1 plus x upon 1 plus x square. Now we will check every option one by one. The first option is if f half is greater than or equal f1. So if x is equal to 1, f dash 1 upon f1 will be ln 1, that is 0. So f dash 1 will be 0. F dash 1 will be 0. So at x is equal to 1, there is a critical point of function fx. Let us say the graph of fx is like this in the interval from 0 to 1. So at x is equal to 1, we can say that if x is less than 1, f at if if x is less than 1 but greater than 0, then we can say that f dash x will be what? From this equation we can determine that. So if x is less than 1, So this will become f dash x is greater than 0, and if x is greater than 1, then the f dash x will be less than 0. So this transmission is going from positive to negative, positive to negative. Its slope of the function fx is going positive to negative. Then at x is equal to a, fx will be maximum. So we can clearly say that f1 will be greater than f1 by 2. So option A is incorrect. Option A is incorrect. So now we'll check another option B. It is given that f1 by 3 is greater than or is less than or equal f2 by 3. So because the graph of fx is going like this, and we know that 1 by 3 is less than 2 by 3, so we can say that f1 by 3 will be f2 by 3, because both 1 by 3 and 2 by 3 belongs to 0 to 1, and in this interval the function fx is maximum. Fx is increasing function. Okay, so we can say that option B is correct. Option B is correct and option A is incorrect. Now we'll check option C. From equation number 1 we can say that if x is greater than 0, sorry, x is not greater than 0, if x is greater than 1, x is greater than 1, then ln x plus 1 upon x square plus 1 will be less than 0, will be less than 0. For example, if x is equal to 2, if x is equal to 2, let's say, then this ln x plus 1 upon x square plus 1 will be ln 3 upon 5. So this is less than 0. Okay, so if x is 1 is greater than 1, then the fx, f dash x, is less than 0. So because 2 is greater than 1, so we can say that f dash 2 is less than or equal to 0, and the option C is correct. So option C is also correct. Now we will check option D. Okay, so what option D says? It says that f dash 3 upon f3 is greater than or equal f dash 2 upon f2. So from equation 1 we will solve for f is x is equal to 3 and x is equal to 2. So for f x is equal to 3, f dash 3 upon f3 will be ln 4 by 10, ln 4 by 10, and for x is equal to 2, this will become ln 3 by 5. So if we subtract them, then this will become f dash 3 upon f3 minus f dash 2 upon f2 will be equal to ln, this will become 2 by 5 and minus ln 3 by 5, so this will become ln 5 by 3 is equal to ln 2 by 3, which is less than 0. So we can say that ln, sorry, not ln, we can say that f dash 3 upon f3 will be greater than, will be less than, sorry, will be less than, will be will be less than or equal to f dash 2 upon f2. So from this result we can say that option D is incorrect. So option C and option B is correct. Option D is incorrect. So these was our four results. Option A incorrect, option B correct, option C also correct, and option D is incorrect. So this was a beautiful question, came in Jee Advanced 2016, and you can download these notes of this class from the description box. And you guys, if you like this question, this solution, then please like, share and subscribe this channel.